Lesson 4.4 is about graphing function rules. This is a two-part lesson. By the end, you should be able to model functions using graphs, tables, and equations and match a function rule to its graph or table. All right, this one's just a little example so you can see where we're going. You are paying to print pictures from your digital camera at the photo shop. You choose one size for all of your prints. What is one possible graph of the relationship between the total cost and the number of pictures that you print? Okay, if you can only choose one size, we can pick whatever we want. Let's go with this 5x7s for 99 cents. Okay, so we're going to need to decide if I bought one picture, only one print, that's going to cost me 99 cents. If I bought two pictures, that's going to cost me $1.99. Oops, sorry, 8. If I bought three pictures, that's going to cost me $2.97. Okay, and so on. So if this is like having our XY table, and these are changing by the same amount every time. They're adding 99 cents each time. Okay, so what kind of a graph should this be? Because it's changing by the same amount, and if I buy 0 pictures, it'll be $0. It should look something like this, straight line. All right, now we're practicing graphing, so what we should do is go over 1 up 99 cents, over 2 up $1.98, and we'd have to mark this side appropriately. Okay, we're going to work on graphing with many other functions today, and we'll just try to do 1 or 2 of each type so that you have an idea of what to do on your homework. They're going to give you a function rule, and they're going to ask you to graph it. If you ask me, making a 3-part table like this is probably the best way to at least start out. On the x's, you get to pick your own x values because there's nothing, they aren't giving you anything other than this function rule. So when you pick your x's, you always have to have 2 negatives, a 0, and 2 positives. So what I usually do is -2, -1, 0, 1, and 2. At least then we have a start and we know what it looks like on both sides, positive and negative. Okay, this middle part is where we show our work so that we can figure out what our y values are. So in the middle, I'm going to take this -2 and plug it in wherever there's an x, and then I'll write my answer over in the y box. So I will have -2 times -2, because that's putting it in place for x, plus 1. Well, -2 times -2 is +4, plus 1 is 5. So now my first ordered pair that I have to graph is this -2, 5. So I'm going to go back 2, up 5. Put my first dot right there. Okay. Then I'm going to do it again, only this time I'm going to plug in a -1. So I'll have -2 times -1 plus 1. Well, -2 times -1 is +2, plus 1 is 3. So my next ordered pair is -1, 3. So I go back 1, up 3, put my next dot. Okay, if I look at this graph, this function rule in the graph, I should be able to kind of tell what kind of a graph this is going to be. This looks like a y equals mx plus b graph. So this should be a straight line, but we have to finish our table to find out. So -2 times 0 is 0, plus 1 is 1, so my next ordered pair is 0, 1, over 0, up 1. Then I have -2 times 1, which is -2, plus 1 gives me -1. So my next is 1, -1, so over 1, down 1. And last but not least, I have -2 times 2 plus 1. So I have -4 plus 1, which is -3, giving me an ordered pair of 2, -3, over 2, down 3. Okay, and there is my straight line graph. Perfect, we were right. Okay, we're going to try another one. Right here, I'm still going to use my -2, -1, 0, 1, 2. Okay, the only thing different about this is now what I'm multiplying by here is a fraction. So I'm going to have 1/2 times -2, which is -1, and then minus another 1 gives me -3. So I go back 2, down 3. Okay, then I have 1/2 times -1 minus 1, which gives me -1.5. So So I go back 1, down 1.5. Okay, this one has the same setup, so this one also should be a straight line. 1/2 times 0 is 0, minus 1 is -1, so over 0, down 1. One half times 1 is 1/2. Minus 1 is -1/2. This one should have been a -2. Sorry. Let's move that dot. Thought it was looking kind of funny. Right there. Okay, so now I have 1 -1/2. So over 1, down 1/2. Okay, and last but not least, I have 1/2 times 2, which is 1, minus 1 gives me a 0. Over 2, up 0. There's our straight line graph. All right, let's try one that maybe isn't going to give us a straight line. Let's try something like this. All right, so I'm going to pick, again, my -2, -1, 0, 1, and 2. And I'm going to plug in what I know. So I need the absolute value of -2, which is 2, minus 4. And 2 minus 4 is going to give me -2. So I'm going to go back 2, down 2. All right, then the absolute value of -1 is 1, minus 4 is -3. So I have -1, -3. Back 1, down 1, 2, 3. Okay, then the absolute value of 0, which is 0, minus 4 gives me -4. So I go over 0, down 4. Okay, absolute value of 1, which is 1, minus 4 is -3. So I'm going to go over 1, down 3. Absolute value of 2, which is 2, minus 4 gives me -2. So I go over 2, down 2. And if you notice, an absolute value graph gives me a V. Absolute value function gives me a V-shaped graph. All right, let's try some word problems here. The function C equals 12.5h plus 30 represents the total cost of renting a truck for h hours. What is a reasonable graph of the function given the daily limit is 12 hours? Okay, first of all, I have my XY chart ready to go, but they're using the letters C and H. This would be your H. This would be your C. Okay, so when I pick times, know that my daily limit is 12, so I don't need anything higher than 12 in my X's. And does it make any sense to have negative numbers? Can you use a truck for a negative amount of hours? No. So I don't need any negatives. And my limit is 12 hours. So there's my range right there. I'm going to just so I can get all the way to 12, I'm going to go 0, 3, 6, 9, and 12. Then I'll know my total range. Okay, so if I plug these in, and I didn't make the long table, so if I worked for 0 hours, so 12.5 times 0 plus 30 would be 30. Okay, if I work for 3 hours, 12.5 times 3 plus 30. Well, 12.5 times 3 is 37.5 plus 30 gives me 67.5. Okay, it's asking you what a reasonable graph of this function is going to look like. Well, this is like a y equals m x plus b. So this is going to be a straight line, and it's going to have an end. So if I were to graph this, which they're not asking us to do, I don't need any of the negative parts, and it's actually going to start up here at 30, because no matter if I've borrowed the truck or not yet, I have to pay this $30, and it's going to go up until I get to 12 hours, and then it's going to be done. It will not continue, so there won't be an arrow. Okay, the other thing that I want to talk to you guys about is other possibilities in graphs. We saw straight line graphs and we saw absolute value graphs, but what if we had a graph that involved something like, if you had like a y equals x squared plus 3. Okay, because of this x squared, you know that that's quadratic. And so your graph should look like a U. Okay, if you have something that has an x to the third power, okay, let's write this down. X to the second power should have the U. X to the third power, remember, is the cubic, so they kind of look like an S. Something to the x power gives us the ones that look like this, and they never quite hit 0. And then the absolute value gives us the V. Okay, so make sure you can double check to make sure you're doing it right to see if you've got the right shaped graph. Okay, this is a 2-part lesson, but your assignment is going to be page 257, 10 through 20 evens, 34, 36, 37, and the lesson quiz.